So here's Gerhard Schmidt's AVR simulator, loading a project at the moment that says blink 1 second, sleep 1 minute in assembler. Now when you start a project with Gerhard software, it'll actually pre-populate a lot of this stuff, including what this package looks like. This is an ATtiny 13A 8-pin AVR, so all that information is in there. Gerhard's made suggestions about where the reset and interrupt vectors are and so forth. They're all pretty standard. I've just changed this one here so that when we get to the watchdog timer, we actually end up going to an interrupt service routine, which is called mytimer_ISR. And here it is, and it actually does nothing because we're just triggering the fact that it's either asleep or awake. So nothing happens inside that ISR, which is actually not such a bad thing. Now here's our main program, so it initializes the stack. Then I've just got an output mode here for PB4, so if we go up here to the picture of the pin, that indicates that pin 1 is indicated by the diagonal there, and PB4 is the one just next to ground, so that's just convenience really, but all the others would work the same. And then the next bit is to enable all the pull-ups on all the ports, and what that'll do is actually turn the LED on. So that's when you come out of main, pull-ups are enabled, and the LED on pin 4, on PB4 is which is pin 3, are actually it's actually on. Alright, so here's the loop. So what does the loop do? Well, firstly it waits a bit, which is a 1 second delay, and then it waits a lot, which is a 1 minute delay, and just repeats. So inside wait a bit, we reset the watchdog timer, and we insert the fact that we want now a 1 second delay, and then we recall the sleep routine, and then we recall something called flip bit, which just, if the LED is on, it turns off. If the LED is off, it turns on. Wait a lot is a bit similar, so this time we turn we reset the watchdog timer. We load up that we want 8 seconds, and then we put a countdown of 6, which is 6, 5, 4, 3, 2, 1, and then 0. So that's actually 7 times 8, 56 seconds we should get out of that. The countdown loop itself just says sleep, which will go for 8 seconds, then decrement the counter, which is R21, and then if it's not equal to 0, go back and do it again. And then finally, we also recall the flip bit routine, which means that if it's LED's on, it's off, and vice versa. Now the sleep now routine, and all this is from the data sheet. Firstly, we enable sleep, we disable the analog to digital converter, which will save some current, and then we do this very timed disabling of the brownout device. So it has to be done according to the data sheet, so that's what that is about here. And then we enable interrupts and sleep. And then when it comes out of sleep, it goes to disable the sleep, and then we're back up and running again. Now when we are back up and running, we need to flip the bit, so whatever's happening on that PB4, there is a flip, so if it was on, it's off. If it's off, it's on. That's the exclusive OR routine here, and finally that returns. That's the entire source code. So let's compile it by assembling, and this is what comes up. So it says yes, it's all fine. It does say it's 54 words. That is 108 bytes, so pretty small. One warning is just that the device has been defined twice, but that's no big deal. And we go to OK. Now what the simulator also does, or the software does rather, is it does a simulation. So we'll do that, which shows you the registers and a lot of other interesting information. We'll actually also enable the ports. So I'll bring that in so we can see what that's happening. We'll go down to updating one instruction, and then we will start. So here we go, we're stepping through. Now there's a big arrow here on the software. It indicates exactly where we are. So this is the point where we are initializing the stack. So we'll see the location of the stack and stored. And away we go. So the first thing to do is to load up into register 16 the value which is indicated by this binary byte, and here it says that PB4 is on, so that's indicated by 16, or here hexadecimal 10. and then we set that out. So we'll just go step. That goes out to DDRB, and the next bit we load up is going to be the fact that all of the pins are going to be set to, or have the internal pull-ups enabled. Now you'll notice here that at this stage we've got the fact that it's set to an output is pin 4, but it's still low. But when we do this one, so we'll just step through that. So there, it's loaded into R16 and out, and you can see the difference it makes down here in the ports. So now we've got all of port B set to high, and what that has is the effect of the one that we've said is going to be output, which is PB4, is actually high, so the LED is on, and all the others have the internal pull-ups enabled. Alright, and we keep stepping, and now we go to reset the watchdog timer. We load up according to the data sheet what's going to give us a 1 second sleep, and we output that, and then we actually go to the sleep routine, and here's the start of the sleep routine here. So this is setting the MCUCR according to the data sheet, and then disabling the ADC according to the data sheet. So that's a power down mode and the ADC off. So that's all good. And then we go to we're going to disable the interrupts, because this next bit needs to be done without interrupts, so that it actually happens in this timed way in case any other process is going. So this is disabling the brownout. So there that goes, and it'll also save power when it's sleeping. Now we re-enable the interrupts, that's SEI, and then finally we sleep. And then nothing much will happen while it's sleeping. So I'm just going to go, not stepping through anymore, I'm just going to go to run, and away she goes. So you'll see here that it's counting. We've got 25 instructions in, and we're now just sleeping. And that's down to around the 7 to 8 microamps while the processor is doing that. Okay, so let's stop that. And what we're going to do now is we're going to actually load it up. So I'm going to use AVR Dude, but via AVR Dude S, which is actually the GUI for that. I can detect that I've got an ATINY 13 connected up, and then I actually load up. This is my blink 1 second, sleep 1 minute hex file, which has been assembled by Gerhardt software, and then I just hit program, and via the slow guy it loads it up, and away we go. So that's the process, pretty straightforward, and then I'll show you what it looks like. So here's the slow guy in action. So I'm about to press the button. There's the upload, there's the 1 second light, and now it's gone to sleep. So here's the programmer that I use, which obviously you can plug an LED into and check that as well. That's the USB ASP, and that's my slow guy doing the job. So here I'll turn on the power. I think I've got it set at 4.1 volts, and we're in micro amps, so it's around 7.7 microamps while it's asleep. Pretty good. That's the circuit working.